Hello friends, welcome to my channel MEP Solution. My name is Priyanshu Maurya, and today we'll talk about ventilation, it is toilet ventilation. I already explained the ventilation definition and method 1 for toilet ventilation, that is ASHRAE standard for 2 meter by 2 meter size of toilet. You can watch my last video, that is toilet ventilation part 1. And someone asked one doubt, like if the toilet size is less than 2 meter by 2 meter, then how to find exhaust CFM and fresh air CFM. So yes, we can use same method, that is 50 and 70 for public continuous and non-continuous, and 25 and 50 for private continuous and non-continuous if the toilet size is less than 2 meter by 2 meter also. But when the toilet size is greater than 2 meter by 2 meter, then we have one another method, that is called ACH method, that is air change per hour method. So what is ACH? Let me explain first. So ACH, air change per hour. Assume here we have one room or toilet, and I am maintaining one ACH, one air change per hour. It means in 1 hour total volume of air will go outside and outside fresh air will come inside. The change of air in 1 hour, only one time the total volume of air will go outside and outside air will come inside. If we are maintaining 2 ACH, it means in 1 hour 2 times this room will empty, means the total air will go outside and outside air will come inside 2 times in 1 hour. We can say in each 30 minutes. In each 30 minutes the air will change. So here we have one formula to find the CFM, that is meter cube into ACH divided by 1.7. So meter cube is that is room volume or toilet volume, length of toilet in meter, width of toilet in meter, and height of toilet in meter, and into ACH, that is air change per hour. Its range is 6 to 10 as per some standards. Here I have NBC, National Building Code of India. So you can see this table, recommended rate of air circulation for different areas. So here I have for toilet 6 to 10 ACH we can consider. Also I have some ACH table you can see here for kitchen, bathrooms. If it is residential, so for bathroom we can take 6 to 7 for ventilation ACH, air change per hour, kitchen, bar, church. So from here also we can consider. Now see, 1.7 is the conversion factor, that 1 CFM is equal to 1.7 CMH. CMH is cubic meter per hour. CFM is cubic feet per minute. This is cubic meter per hour. So cubic meter into ACH, it will be cubic meter per hour. Cubic meter hour. But what we required? CFM, cubic feet per minute. So divided by 1.7. So we will get CFM. And if the dimensions are in feet, then we can use cubic feet into ACH divided by 60. Why? Because cubic feet into ACH, it will be cubic feet per hour. We require cubic feet per minute, so divided by 60. So length will be in feet, width will be in feet, and height will be in feet. Length, width, height of the toilet. Now let's consider one example. Here I have 1, 2, 3, 4, 5 toilets and one wash basin area. So this total considered as the passage area, and we have 5 toilets. Let's see what is the toilet size. See, height is given 2.5 meter, you can see here. So toilet size is 3 meter, 3 meter by 3 meter. Each toilet size is 3 meter by 3 meter, and the height is 2.5 meter. So let's assume here I am using ACH. We can't use here ASHRAE standard. I'm using here ACH is equal to 8. So where we can use 6, where we can use 10 ACH. So if it is residential building, we can take 6 ACH. If it is commercial building, so we can use 7, 8 ACH like that. If it is a hotel or a shopping mall, we can use 10 ACH also. So I am using ACH 8. I'm just assuming 8 ACH. And length of toilet is equal to 3 meter. Width of toilet is equal to 3 meter, and the height of toilet is equal to 2.5 meter. Now what will be exhaust air from one toilet? Exhaust air from one toilet is CFM is equal to, it will be meter cube, that is 3 into 2.5, that is meter cube, into ACH is 8 divided by 1.7. I am writing 8 here only. This is the ACH, 8 divided by 1.7. So this is meter cube, 3 into 2.5. ACH is 8 divided by 1.7, because units are in meter, so I am using this formula. Okay, so now let's find out the total CFM will be. Let me open the calculator. 3 into 2.5 into 8 is equal to 180 divided by 1.7. It becomes 105.8. We can say 106 CFM. This is our exhaust CFM from one toilet. So now from 5 toilet, exhaust air is equal to, exhaust air means waste air, so it will be 5 into 106. So it will be, here also we can write the formula 5 into 106. Give the equal symbol and then 5 into 106 and then enter. It is 530 CFM. Now the fresh, okay, now we have passage area also. So for passage area, 1 square feet is equal to 1 CFM. So let's find out first passage area. So here we have that total CFM. Let me do it bold. So passage area is here. Let me use DALI command, dimension linear. Here the size. Okay, this one is 3 meter, and this one is also 3 meter from here to here. Not 3.1. Three meter by 3 meter, and length of the, okay, it is 2.6. From here to here it is 2.5, and the length of passage area is 9.2 meter we can consider. So we can calculate like this area plus this area that length, and this area. So here we can write 9.2, this is in millimeter, so 9.2 into 2.5. So passage area is equal to 9.2 into 2.5. This is one area, plus 3 into 3. Let's find out the area. 9.2 into 2.5. So first use equal command if you want to calculate in Excel sheet only. 9.2 into 2.5, close the bracket, plus open bracket, 3 into 3, close the bracket. So it becomes 32 meter square. So we will convert into square feet. So we know one square meter is equal to 10.76 square feet. So let's convert it in square feet. So is equal to this one into 10.76. We will multiply that square meter into 10.76. It will convert into square feet. So that much square feet the area. So CFM will be the same. So 344 is equal to this one only, 344 CFM, because 1 square feet is equal to 1 CFM, then 344 square feet is equal to 344 CFM. I am doing it also bold. So now total exhaust air is equal to, here we will add total value, is equal to 530 plus 344, 874 CFM. And now fresh air requirement. Fresh air, because we require fresh air. If we don't provide fresh air, then this area will go under negative pressure. So when we are removing some air, then we must provide some fresh air. So you know fresh air, how much we consider? 80% of exhaust air. In last video I explained we maintain negative pressure in the toilet, so it will be is equal to 0.8, that is 80%, sorry, 0.8, 80% it is, into 874 is equal to 699, you can say 700 CFM. This is our fresh air. So here we have total exhaust air and total fresh air. So now see, when why we are using negative pressure in the toilet, because when we are using when we are using 100 CFM to remove, and we are adding 100 CFM, so pressure is 0, but when we open the door from here, some smell can go outside. But when we are removing 100 CFM and providing only 80 CFM, 80%. So this area is still in a negative pressure of 20% CFM. So when we open the door, so this side of air will not go outside, outside air will come inside. So we can avoid the smell to pass from the toilet to our spaces, another spaces or hall, kitchen, anyway. So this is about the toilet ventilation and the drafting. See, here we have the drafting. So the same, this is the old one. I will explain the drafting also in my next video. So please like, share and subscribe if you like it with your friends. It is very useful. Okay then, goodbye.